Next speaker is talking about Ethereum research for sustainability and scalability. Please make him feel very, very welcome. Put your hands together for Leonardo Bautista Gomez.
Thank you. Okay. Can you hear me? Yeah, okay. Thank you. Yes, so good afternoon. My name is Leo, and I'm going to talk a little bit about the research we are doing on Ethereum for sustainability and scalability. This is part of our research group, Mega Labs. And so just before starting, I want to introduce a little bit myself, and so that you know my trajectory and where I come from. This is not working, apparently. Okay. All right. So yeah, I come from Latin America. I was born in Nicaragua. I grew up in Colombia. I did a bachelor in computer science in Paris, and master in distributed systems. I did a little bit of PhD on supercomputers at Tokyo Tech, and then did some research on scientific computing in Chicago. And at that moment, then I came to Barcelona to work at the Barcelona Supercomputing Center. I work in scalability for supercomputers and scientific computing. And in 2018, I started to realize that the scalability issues that blockchain technology has were very, very similar to the supercomputing world, and the same kind of problems we talk about, resilience, performance, scalability, and all that, are kind of very similar to what I did for my studies. And so at that moment, I decided to kind of join this adventure in trying to make blockchain technology more scalable. And so at that moment, I started to do research with the Ethereum Foundation. This was the first meeting we had. I think it was in Taiwan in 2018. So I have been doing research with them for the last 5 years. And since then, we had I received 5 grants from them, and we have done a lot of different projects, and what today I want to present is some of those things that we have been doing on the last few months. So there are 3 main topics that I want to present. First, I'm going to talk about the peer-to-peer network for Ethereum, and the crawler that we have developed, and the data that we managed to gather using this crawler. Then I'm going to talk a little bit about the transition to proof of stake, basically the merge, and the analysis that we did on rewards for staking institutions. And then also, I want to present a very new product or service that we introduced that is a staking monitoring platform where you can actually see the Bitcoin chain being built in real time and basically all the things related about staking. So let's start with the Ethereum peer-to-peer network. So we created this network crawler that is called Armiarma. It's an open source crawler, so if you can access the code, you can just take a look at the QR code in the screen, and you can download the code and use it yourself. It's completely open source. We also published an article in a scientific conference a couple of years ago describing how the crawler works. So if you have more of a technical background, perhaps this is the kind of documents that will make you understand how this crawler works. So I don't want to get too much into the details about how it works, but I want to present more or less the kind of data that we managed to gather with this crawler. So for that, we just launched last week this dashboard that is online. Again, you can access it with the QR code in the screen. And so we have 2 dashboards. One is for the Bitcoin nodes, and the other one is for the Bitcoin validators. All right? And I'm going to present some of those results. So for example, one of the things that we can know with this crawler is how many nodes are active in the network. So this crawler is trying to connect with as many peers as possible in the peer-to-peer network, right? And every time we connect with a node, we try to gather some basic data about the nodes, and we put all that in a database. And so here we can see more or less there are about 12,000 nodes in the Ethereum network. And we also can know the geographical distribution of those nodes, right? Because to connect with them, you need to contact them through their IP. And when you have their IP, you have more or less a good idea about the region where they are located. And so you can have a good geographical distribution about the nodes in Ethereum. Now, this is very important, actually. There are many people that are interested in this, because there are many efforts right now on trying to decentralize even more the network, geographically speaking, right? Because there are countries that might be wanting to shut down kind of blockchain operators in some countries. And so that's why I think it's important to decentralize that, the network as much as possible, right? But we don't know how to decentralize it. We don't even know what the network looks like today, right? So that's why I think these kind of pictures help us, understand the current state and to understand also where we want to go, right? So right now, most of the nodes are in the US. There are many in Germany, in France, some of them in Australia, Russia, etc., right? But we want something that looks more red across the entire world instead of just one single point. Now, another type of diversity that we want is software diversity, right? When you are running a network with 12,000 nodes, and for example, everyone is using the same software, the day that that software has a bug, your network is down, right? And so client diversity is very important. The Ethereum Foundation put a lot of effort in funding 5 different teams with 5 different implementations in different languages, and so that makes sure that the system is robust in terms of software diversity. So right now here, this is data that we gather with the crawler, and we can know that more or less Prisma and Lighthouse have about 40% of the nodes in the network, and then 10% and 7% for Teku and Nimbus, respectively, and then the few others are smaller proportions. This image right now is much better than what we had 1 year ago. 1 year ago, like 70% of the nodes were using one single software, one single client, right? So now we managed to get a little bit more diverse, and if one of them is not behaving well, or there is some backdoor introduced by accident or not, we have a system that is still reliable because there is this software diversity. We published this scientific paper a couple of years ago that actually analyzes the performance of the different consensus layer clients. So if you're interested, you can take a look at it. And so one of the things that I want to mention also is that we actually provide this data for free to the community and to the website clientdiversity.org, which is this effort to improve client diversity in Ethereum, right? And so if you look, the data that they're providing in their website actually is data that we are providing to them. And if you look at the execution layer client, for those that know how a node runs in Ethereum, you need 2 clients, one consensus layer and one execution layer. And in the execution layer, you see that 50% use Geth, which is not good. We want more diversity on the execution layer client. And this is actually much better than before. Like a year ago, 80% of the nodes were running Geth. Now we have more Nethermind and others. So the software diversity is changing a little bit, is improving in the execution layer clients. But again, we need to know where we are, and we need to know where we want to be. Another thing that we might discover with this type of crawler is where the nodes are located, right? And so we know that right now about 50% of the nodes in Ethereum are in clouds, and about 35% of the nodes are in homes. Now, how do we know that? It's because we have their IP. When we have their IP, we can know their ISP, right? So you have the internet provider, and the internet provider finished by Amazon Ltd, then you know that's a cloud, right? And if it's, I don't know, Vodafone or something like that, it's most likely to be a home, right? Now, another thing that we know from the network is how many attestation networks these different nodes are subscribed to. For those that know what attestation means and what staking means, here you can see that for about 6,000% of the nodes, 6,000 of the nodes they are not subscribed to any attestation network, which means that most likely they are not having any validator behind. So these are non-staking nodes. These are just nodes that are running, and they don't have any validator behind. And then you have what we call the home stakers. So those are nodes that have between 1 and 10 validators behind them. And then on the other side of the screen, you have those that are subscribed to 64 attestation network, which is the total maximum that you can register to. And these are most likely international stakers. And of these, you have more or less like 1,000 of those nodes. These are most likely, big operators like Lido, Kraken, Binance, Coinbase, etc. Now, another thing that we do, we collaborate with the University of Cambridge. They built this dashboard that shows the energy consumption of the entire Ethereum network. Originally, they had this for the Bitcoin network since several years ago. But now they built this dashboard that estimates the energy consumption of the Ethereum network. And they estimate this based on the data that we provide to them, like things like the number of nodes and the client diversity and so on and so forth. So this is something that is also possible to do thanks to the crawler and the software that we have developed at Mega Labs. Now, I was talking about the beacon nodes in general. Now I want to give a very quick overview about the validator nodes. So these are nodes that are validating, that have validators behind, and we know that because they are subscribed to at least one attestation network. And so you see the geographical distribution is more or less the same. The software distribution is actually better. OK, the laser is not working. The figure on the left shows that it has a much better distribution. It's like 35% for Prism, 30% for Lighthouse, 15% for Teku, and 10 or 11% for Nimbus. So it's a much better distribution in terms of client diversity if you only focus on the validator nodes. Regarding the hosting, is more or less the same, 50% of cloud nodes and 35% of residential homes. We also see that there are about 10% of the nodes that run in ARM, which is actually something good. We want to be able to have validators running in small devices that are not very energy hungry. And so this is a good thing. And yeah, more or less, we see about 5,600 nodes that are validating in the network. OK, transition to proof of stake. That's another work that we did. So we published this paper that, if you're interested on all the details, you can take a look at the paper. It shows more or less the reward system before and after the transition to proof of stake, so basically the merge. And we also built this kind of visualization dashboard that allows you to compare multiple entities. Like, for example, you take Kraken, and I say, I want to see how they perform before the merge versus after the merge. So there is this website that is called Panda Metrics. You have the QR code if you want to take a look at it. And you have all the different entities, and you can click on an entity and see how they perform before and after the merge. And you can, if you click on them, you have actually the entire list of validators. And you can see how every different validators perform in terms of rewards. Basically, what we are trying to check here is the bars that you see here is how much rewards you managed to get versus how much you actually could get, if you have done a perfect job as a validator, right? So this is the kind of things that we did for the merge. You have the paper and the visualization dashboard online in case you were interested in that. Finally, I want to talk about the new staking monitoring tool that we developed. Again, it's an open source tool that shows a lot of data. It's called etseer.io. You can access it on the QR code. Okay, so let me try to explain a little bit what you see in this screen. First, on the top, you see basically the summary bar, where you can see in which epoch we are, the slot, the block height, and the number of validators that are active right now. And then here in the middle, you see basically the blockchain being built in real time. So you will see blocks appearing now. This is a static picture. This is just a screenshot. But when you go in the website online, you will see the blocks being created one by one after the other. If you know a little bit about how Ethereum staking behaves or the consensus protocol, you know that there is 32 slots in an epoch. So basically, there are a group of 32 blocks. And these are the boxes that you see here. So you see 2 epochs, and each epoch has 32 blocks. And we also, the color and the logo that you see on the blocks is which entity is producing that block. So you know, for example, the one on the top right corner is a block that was proposed by Kraken, for example, right? And then 3 later, I think, is Binance, and so on and so forth. You can see which entity is producing each block, and we know this because we know which validators belong to which entities, right? And so basically, in real time, you can see which are the actors that are playing, that are building the blockchain that we are all using, right? And then on the bottom, what you see is the statistics of every single epoch. So every row that you see there is an epoch. And what you see there is a lot of information about the number of blocks that were produced, the number of blocks that were missed. If the block is missed, you will see a red cross on the block. You can also get information about the attestation accuracy. We want that, hopefully, the attestation accuracy is always above 99% in the ideal case. And we also get information about the total voting participation. And so in a healthy network, we want 99% of the validators doing their duties according to what they are supposed to do. So we want the voting participation to be very high, so 99%. So basically, this gives you an idea about the state of the chain in real time. A couple of weeks ago, or a month ago, there was a problem in Ethereum chain. It was not finalizing for several epochs, and we actually could see this in real time in our dashboard. We saw that the participation was getting down, blocks were being missed, and so it was red everywhere, and we didn't know what was happening. But it was really interesting to see that actually you could actually visualize this in real time in our dashboard. In addition to that, you can actually click in an epoch, and this is the image that you have on the right, and you get all the details about that specific epoch. How many blocks were proposed, how many blocks were missed, how many attestations were sent, how many attestations were missed, the active balance, and you can see the whole list of all the blocks. And for every block, you can see the entity, the proposer, the slot, the date, the withdrawals, every single detail you can know on this dashboard. And then on the left side, you can see the validator view. So you can see how this validator has been performed over the last 12 hours. You can see how many rewards it got versus how many rewards it could have gotten. And the attestation misses, the blocks that has produced since the beginning of time, also the withdrawals, and so on and so forth. We also have a view for the slot where you can see the consensus layer information, the execution layer information, and the withdrawals. So basically, very much detail about everything, and there are also information about the entities. So we have a page where we can actually visualize, for example, Kraken, and I can see how many active validators they have, how many validators they have exited, how many have been slashed, and so on and so forth. And we are also going to give statistics about each one of those entities in the near future. And again, so all this is open source for free and available for everyone to use. Now we're working on an API so that everybody can access this data in an automatic way through this API. And hopefully, this is going to be a lot of help for staking entities and for validators, even solo stakers, to get real-time information about how their nodes are performing, how their validators are performing, and so on and so forth. So yeah, just to finish, I want to say a big thank you to our collaborators. These are the entities we have been working with over the last 6 months, a year. So we got several grants from the Ethereum Foundation, a grant from Lido. We also have been working a little bit with Obol on distributed validator technology. I didn't have the time to present this today, but yeah, we have been working with us. If you're interested in knowing to that, you can come talk to me after the talk. We work with Cambridge University, as I mentioned. We also work with Attestant, which has been supporting us for quite some time already. And yeah, we collaborate with the Status and EtherAlpha. So all this work has not been done by me only. Actually, it's a group of it's a team of members that has been working very, very diligently, very bright and enthusiastic people that have been working on this. So I want to thank all the team, which is actually sitting in the back. And so all that's all I want to say. Thank you very much for your attention.
Leo, everybody. Nice. I got the clicker here.
I think it's not working yet.
It's not working?
Well, it's stopped working, but it's fine.
OK, cool.
Thank you.
Yeah, you've got 2 minutes if you want to do a question.
Yeah, if anybody has any question, I can answer questions otherwise. Yes?
Can we do a PR so blocks produced by DAppNodes will have like a nice logo like Kraken and Coinbase?
Yes, definitely you can do that. Any other question? All right, thank you very much.